Graphically, let's look at the equilibrium interest rate and then output. Okay, so this is our LM curve, IS curve, and then this is our LM curve. So where these two curves meet, then we have our equilibrium point. Okay, so this is LM, this is IS, and this is our equilibrium point. This is equilibrium income, we call it Y star, and then this is the equilibrium interest rate. Okay, equilibrium interest rate. So this is our equilibrium point. So most of the times when they give the questions, of course, you'll be asked to find the Y star and then the E star. And also we looked at the shifts in the IS and then the LM curves. What is going to happen to IS curve, assuming there's an increase in government spending? And we saw that that is going to cause an upward shift in the IS curve. Okay, so it means that this is going to be the new equilibrium point, and with that, there's going to be an increase in output. Okay, output to increase, and then interest rate too is going to increase. Assuming there's an increase in tax, if there's an increase in tax, that is supposed to cause a reduction in the IS. So for this one, interest rate falls and then output to falls. If there's an increase in the money supply, then LM curve will shift like this, and then this is going to be the new equilibrium. So for today, we'll just be looking at the algebra, how to derive Y star and then R star. We saw an example. Then later on, we'll look at the policy effectiveness. If there's a monetary policy, how is it going to affect the R star and then the Y star? And then graphically too, we have to know how to use the graphs to look at the policy mix. Okay, so that's what we'll be doing today. All right. So first, we'll start by looking at how to derive the IS curve. Then we'll also do same for LM. We said that the IS curve is derived in the output market. Okay, so it's just the combinations of equilibrium interest rate and then output. So when we go to the output market, we have our consumption function. C0 is our autonomous consumption. C1 is the marginal propensity to consume. YD is the disposable income. And then investment, when we're doing the loanable funds market, and then when we're treating the liquidity preference theory, okay, the demand for money for the for transactive and then precautionary motive for holding money. We saw that when we're talking about the loanable funds market, we saw that uh, in, investment was negatively dependent on interest rate. Okay, investment depends on interest rate, but the relationship is negative. When interest rate increases, then investment falls. And also, investment depends on income. Okay, there was an assumption that investment is equal to savings. That firms normally go to banks to go and borrow the money that people save. Okay, those who supply loanable funds, and the amount of money that we can save depends on the income that we have in the economy. So, in some questions, investment doesn't only depend on interest rates, but it also depends on the level of income. But for that one, the relationship is positive, which means that with higher income levels, we expect investment to be high. Okay, so and then this I0 is autonomous investment, the level of investment when interest rate is zero and then income to is zero. Then government spending is taken as autonomous. So Gen is equal to Gen 0. And then YD is equal to Y minus T. Disposable income is income minus tax. For the moment, limit the tax to just the lump sum tax, autonomous tax. So there's no income induced tax. So let's just stick to this one. But in case you have a question where we have the TY, the small TY, I mean, we should be able to do that. So when you go to the output market, if you want to get the IS curve, you can either use expenditure is equal to output, what I have here, or you can use the leakages and then the injections approach. All right, so if we want to use the income equals expenditure approach, then y should be equal to the sum of consumption, investment, and then government spending. Okay. So for consumption, this is the consumption function. Okay, autonomous consumption, and then marginal propensity to consume, and then disposable income. When we go to investment, we have autonomous investment, and then the uh, interest elasticity of investment. We call it the R1, and then there's our interest rate. Then this is it's part of the variables that measure the income elasticity of investment. And then we have our government spending, which is a J0. Okay, so that's what we have. Now we know that YD is equal to Y minus T. Okay, Y minus T. Okay, Y minus T. So that's what we have here, and then this part 2 is there. So we have Cy times Y minus T, so we can expand. So when we expand, we get C0, then C1Y minus C1T. Okay. What you have to take note is that it's not always that you see C0. In some books, you see the autonomous consumption as A, then C1 is B, marginal propensity to consume. I mean, it doesn't matter. It's just a matter of variables. Okay. So that's what we have here. Now we want to make Y the subject. Okay. We want to make Y the subject. So we have to send all the terms with Y to the left hand side. So we have C1Y here. So we have Y minus C1Y. Then when you come here to, we have I2Y. So when you bring it here, we are getting minus I2Y is equal to C0 minus C1T plus autonomous investment and then government spending minus I1 times interest rate. Okay. So I'm calling this so the autonomous expenditure. So that's what we have here, the A bar. I'm calling it the autonomous expenditure. And then here too, when we factor y out, we get 1 minus C1 minus I2. So that's what we have here. 1 minus C1 minus I2. So this is equal to A bar minus I1R. Okay. So here I factored minus 1 out so that this one's become positive. Okay, so if you want to get your y star, you just divide through by 1 minus C1 plus I2. Okay. But just know that in case there was the marginal tax rate, if there was a tax rate, then the denominator here was going to change. Okay. So depending on how the question is. Okay, so this is our IS equation. Okay, this is our IS equation. You can also choose to write it in terms of R. Okay, you can write it in terms of R. But just note the negative sign here. Okay, the negative means that for the goods market, there's a negative relationship between output level and then the interest rate. Okay. I prefer making R the subject because at times we are asked to find the slope and that is the R dy. Okay, the R dy. So you have to, if you want to find it, you just differentiate R with respect to y. You differentiate R with respect to y, then you get the slope of the IS curve. Okay. Any question? Any question? Okay, I guess there's no question, so we can move on. All right, so this is what I was talking about. This is the R dy, and this is going to measure the change in R resulting from a unit change in y. Okay, if equilibrium income should increase by 1 unit, then the interest rate will fall by this value. Okay, it will fall by this value because of the negative sign. So that's what we use the RDY for. We will be using it in the questions. We normally use it. So you need to know, even at times you'll be asked to give an interpretation. Okay, so you know first how to find the DRDY, to how to interpret it, and then also how to use it. We'll look at both in, in, in a numerical question. Okay. All right, so that is for the IS curve in the goods market. Then when we go to the money market, we have money demand and then money supply. Money supply is taken as autonomous. Okay, and then the money demand function depends on autonomous money demand. The part that doesn't depend on income or interest rates. This is what I was talking about earlier. For the liquidity preference theory, we saw that the precautionary and then the transactionary motive for holding money is positively related to income, which means that the higher your income level, the higher the amount of money that you hold for transactions and then precautionary purposes. And then we saw that based on the speculative motive for holding money, the money demand function is negatively related to interest rates. So when interest rates are high, people tend to hold bonds and then hold less money and vice versa. So this is a typical money demand function. But just know that it is not always compulsory that you have all these things. It's possible they will not bring M0. It's possible that they will not bring this thing M1Y. It depends on the question. So don't restrict yourself that the thing should always be like this. No, you work with the question, what was given in the question. So if you have the Y term, you use it. If you have the, as for the R, it has to be there. This one too has to, but for this one, most of the times they might not be bring it. But I wanted us to bring it so that in case you see somewhere, you know that there's also an autonomous part. And yes, we want, in reality, I mean, for the money that we hold, we don't really depend on interest rates, and at times too, it's not really dependent on our income level, but we still hold some amount of money. Okay, so the LM schedule is determined in the money market. Okay, so in the money market, we have equilibrium when money demand is equal to money supply. So we equate the money demand function to the money supply. Now, we want to make R the subject. Okay, so we can bring this one here and send the money supply to the other side. So this becomes positive, then money supply comes here, becomes what? Negative. So we have M2 R is equal to this whole expression. Okay, so now if you divide through by M2, then you have your LM equation. So R star is equal to this, R is equal to this. Okay, so this is your LM schedule. Okay, I'm sure you know that whenever they increase money supply, there's a fall in interest rate. This is the reason. You see that the money supply is negatively related to income, to interest rate. So whenever you increase money supply, then interest rate is supposed to fall. Interest rate is supposed to fall. This one too, if you want to find the slope, you differentiate R with respect to Y. Okay, so if you look at this, if you differentiate this with respect to Y, we are getting M1 over M2. Okay, M1 over M2. So that's what we have here. So this means that you see that the coefficient is positive. So what this means is that when you increase your income in the money market, oh, when you increase your income by 1 unit, then interest rate will increase by this value, M1 over M2. Okay, you see that here they are positively related. All right, so that is that for IS and LM. Please take note that I hardly doubt there will be a macro one paper without a question on IS and LM. It will really be hard. Okay, the questions are mostly on this one, and then the labor market, the one that we did before the Keynesian. You get one of this, one of that, then those intuition questions. So please let's take it serious. But this is what the macro is all about. Okay, this is what the macro is all about. So this is an example. Okay, this is an example. These are the uh, equations that we have from an economy. This is our consumption function. This is our investment function. Government spending, tax, money demand. You see that this one they didn't bring the autonomous. Okay, they didn't bring the autonomous, and then money supply is giving us 1,600. Okay, the first question was where to find the uh, IS and then the LM equations and interpret their slopes. That was the first question. I think somewhere here. This is it. Okay. So these are the uh, equations. Okay. Then the first one we have to derive the IS and then the LS equations and interpret their slopes for 5 marks. I mean, you can just use 2 minutes, get your 5 marks, you move on to the next one. As for the macro, is very easy. The macro is easy. I'm sure we will do well. Okay, right. So first, let's get our eyes. So Y is equal to the sum of consumption, investment, and then government spending. So this is our consumption function. 200 as the autonomous consumption, 0.25 as marginal propensity to consume, and then we have our disposable income. Then 150 is autonomous investment, and then we have the 0.25 Y minus 1,000 R. This is government spending, 250. Okay, 250. So now I added all the autonomous components, 200 plus 150 and then 250. I'm sure that is giving us 600. Please be checking it too. I am not good in math, so be checking it just in case I make a mistake. Then for YD, we know that YD is equal to Y minus T. YD is Y minus T. Okay, income minus tax. Income minus tax. Okay, so the tax was giving us 200. So YD is equal to Y minus 200. Then we have 0.25Y and then our 1,000R. Then when we expand this, we are getting 0.25Y minus 0.25 times 200 is 50. Then plus 0.25Y minus 1,000R. Minus 1,000R. Okay. So now 600 minus 50 will give us 550. 0.25Y and then there's another 0.25Y. When we add them, we get 0.5Y minus 1,000R. Now we have when we bring 0.5Y here, we have Y minus 0.5Y, which is 0.5Y is equal to 550 minus 1,000R. So Y is equal to, we divide through by 0.5. So we get 1,100 minus 2,000R. So this is our IS. You can choose to make R the subject. Okay, so this is our IS equation. 0.5 and a half. Who divide it into a better times two. All right. I hope we all understand. Oh, please say something. Eh?
Yes, sir.
Honorable Mensa, do you understand?
Yes, please, I understand.
Honorable Niama,
Yes, please.
Lizzie, Lizzie. All right. So we have our IS curve. Let's look at the LM. In the money market, we have equilibrium when MD is equal to MS. So for the money demand, the equation was 2y minus 8,000 R, and then money supply is 1,600. We want to make R the subject, so we can send this one here and bring this one here, so that the negative sign disappears. So now we have 8,000 R is equal to 2y minus 1,600. So we divide through by 8,000. So here 2 over 8,000 will be 1 over 4,000. 1,600 divided by 8,000 is 1 over 5, 0.2. So that's what we have here. So this is our LM equation. Okay, our LM equation. Now, the second part of this question was to find the slopes and then interpret them. So for the IS, we differentiate R with respect to Y. So when you come to the IS curve, you can make R the subject here so that the differentiation will be a bit easier. Okay. So when you do that and you do the differentiation, the R dy is minus 1 over 2,000, which is minus 0.0005. So it means that if Y should increase by 1 unit, interest rate will fall by 0.0005 units. I hope that's understood. And then for
Hello.
Dima,
Sir, please, can you come again on the slope of IS?
is it the differentiation or the interpretation?
The differentiation and the interpretation.
Okay, for the differentiation, to make it easier, you have to make R the subject here. You see, we have to find dr dy, but dr dy is equal to 1 over dy dr. So dy dr here is minus 2,000, right? When you differentiate y with respect to r, we get minus 2,000. But we are looking for dr dy, so we divide it by 1 over the answer. But you just make R the subject here. Okay, make R the subject.
Okay.
When you make R the subject, you get R is equal to 1,100 minus Y all over 2,000. So when you differentiate, you get minus 1 over 2,000, which is minus 0.0005. So what this means is that if um, income should or output should increase by 1 unit, then interest rate will fall by 0.0005 units. Is that okay?
Yes, sir.
Okay. And then when you go to the LM, you differentiate R with respect to Y. That's this one. So the R dy the coefficient of y is 1 over 4,000, which is 0.00025. 0.00025. So this one too means that in the money market, if income should increase by 1 unit, interest rate will increase by 0.00025 units. Is that okay?
Yes, sir.
And then the next question were to find equilibrium y and r. Equilibrium y and then r. Now, uh, this is simultaneous equation, okay? So how you want to solve it really depends on you. But from this IS equation, you see that y is equal to a function in r, okay? And then for LM2, we have r being a function of y. So here, instead of this r, we can put this whole value there, where y over 4,000 minus 0.2 into the IS equation, so that we will only get a linear equation in y. So we can get our y later on. We come here, we put it here, and then we can get our r. Okay. So that is what I was doing here. We have to put the second equation into the first one. So y is equal to 1,100 minus 2,000 r, and this is the value of r from the LM equation. Okay, from the LM equation. So we expand 2,000 times 1 over 4,000 is 0.5. So we have 1,100 minus 0.5y. Then minus 2,000 times minus 0.2 will give us positive 400. Okay, 400. If we add 1,000, hey, look at how I've written 1,100. Okay, this is not supposed to be here. Okay, it's 1,100. 1,100. Okay, so minus 0.5y plus 400. If you add 1,100 to 400, you get 1,500. Then we send minus 0.5 to the left hand side. So we get y plus 0.5y, which is 1.5y, is equal to 1,500. If we divide through by 1.5, we get y star is equal to 1,000. It means that the equilibrium uh, output or income is 1,000. Any question? Any question? All right. So now that we have y star, we can go to the LM equation and put our y there. So our star is equal to 1 over 4,000 times y. So y is 1,000 minus 0.2. If you simplify this, you get 0.05, which is 5%. So the interest rate is 5%. Interest rate is 5%. I think that one too was 5 marks. 5 marks. So by now you have 10 marks. So you have 10 marks. You have to find the values of consumption and investment in this equilibrium and verify if these values are correct. Okay, so we have to find C and then I, C and I, C and I. So consumption, we just go there. We have Y, we know T, we just do substitution. Okay, so consumption is equal to 200, 0.25 YD, and the YD is Y minus T. Now we know our Y to be 1,000. So disposable income will be 1,000 minus 200, which is 800. Okay. So when we simplify this, we are getting 400. So consumption is 400. Consumption is 400. And then investment too. This was 0.25y, 1,000 out. You just put them inside. You get your investment. So now we have 350 for investment. So we were to verify. How do we do that? How do we verify? Yes, who can help me with the verification? How do we verify these answers? Is it really correct? We went through. Okay. We know that at equilibrium.
Hello, sir.
Yes.
Hello.
Yes.
Sir, please, I'm lost. My network, so I'm not getting what we are doing. What are we solving for right now?
Uh, do you, and I hope you understand how we got income and interest rate.
Yes, yes, I
Good.
understand.
This one were to find consumption and investment. So
Okay.
what you have to do is you take your consumption function. Consumption is 200 and then 0.25 YD. But YD is what? Y minus tax. And from the equilibrium Y,
Okay.
we had 1,000 and tax is 200. So disposable income will be
Yeah, I
1,000
get it.
times 200. Okay. And then for investment, to put your Y here, put
Yeah.
your R here.
Mm.
All right. But
Thank you.
Lizzie, what network are you using?
Airtel to go.
Yeah. You are the one using the internet. But I think I remember we advised you to change it.
Very soon.
Yeah,
I will.
um, I think they are not helping us. Okay, so we know that at equilibrium the leakages are supposed to be the same as the injections. Okay, leakages are supposed to be the same as injections, and these are our injections: government spending and then investment, and then the leakages are savings and then what, tax. Now, how do we find savings? Yes, how do we find savings? How are we supposed to find savings? Or we have income, we have consumption. How do we find savings?
Hello.
Yes.
Income minus consumption.